Alright, let's go ahead and graph this. Sebastian, can you tell me the letters above it? Raise your hand if you got that so far. Sebastian, tell me your A value. So step 0, ID your A, B, C's, and D's. So your A value is -1. Your B value? Yep, there's no number there, so these are 1s. C value? So it'd be a 0. And your D value? 0. Partner A, tell partner B, what do each of these letters eventually tell us? What kind of information can we get? 30 seconds, right? Second. Alonzo, what does the A value normally tell us? It normally tells us the amplitude, but what did we just write down, class? It's a fake. Okay? So, although you're getting an amplitude of absolute value of A, and you normally think this, right? This is not real, it's fake. And I'll explain that later when you see it. Partner B, tell partner A, what's the formula for the period for tangent? Diane? Yeah, period equals pi over b. We just wrote that down. Common mistake for students when they take their next quiz or test, they're going to get confused between the two of these. So you have a formula sheet, so pretty simple. So class, our period is going to be what? Pi. Okay. Students were stuck on the quiz. What to do with this? Remember, you can actually put this between, although class is there a horizontal or a phase shift? Well, we could just interpret it with the C value. The C value, class, is there a C value? No. So no what? No phase shift. Okay, students didn't know when to put between 0 and 2 pi. You put it between 0 and 2 pi when there's a C value or parentheses, correct? Now, it wouldn't be actually wrong if you said, well, there is no phase shift, so I don't have to do that. You could do that and you stick at the same answer. You would basically put this between x between 0 and pi, and that would tell you where you're starting at. Does that make sense? Class, your D value is what? None. So what does that tell us? No vertical shift, right? Partner B, tell partner A, what's step 1? Maria Bellin, what is step number 1? And do we already have that? Yep. What's the next step number 2? We're going to get our 5x values. Let's get our 5x values. So to do that, you might want to make a table. For this graph, it's going to look kind of crazy. So I'm actually going to do my table of values up here. Table of values. And then I'm going to do my graph down here, just because it's kind of crazy. It would be kind of crazy if there were snakes on the floor. Alright, class, how many x values do I normally write? 1, 2, 3, 4, 5. Partner A tell partner B, or do this together, 30 seconds. I want those 5 x values. Ready, set, go.
This is 3.2.
Divided by 2. So what I'm going to do is put whatever you have here, over 2. So that's 5/2.
Alright, Sarah R, what do I get here? Sarah R over here. Yeah, so remember, your period is going to go here. And because there is no phase shift, you're always starting at the origin. 0 and pi. Sarah R, if you divide that in 2, right, you add those two together and divide by 2, what do you get here? Pi and a half. Uh-oh. Now, let's make this one a fraction, but with the denominator of 2, so you would have to have equivalent fractions. Sarah R, how do I make that a fraction? Good. So I'm going to get 2 pi over 4, and this is 0 pi over 4. Class, this one will become what? No, what did I do? 2 pi over 2. Try that again. These are 2's. I was thinking ahead. And we're going to have to double those, yeah? So class, if I double these, what do I get? 4 pi over 4. This one? 2 pi over 4. And this one will become 0 pi over 4. We're just multiplying the numerator and denominator by 2. That means, Sarah, this one's going to be what? Correct. 1 pi over 4. This one? Yep. So, some students are asking, why do you do all these fractions down here? It's to show equivalent fractions, and you can just count 0, 1, 2, 3, 4. See that? And then now I'm going to go ahead and circle the ones we're actually going to use, and this will actually be super helpful as you evaluate them. So essentially, we already know that this is just 0, pi over 4, pi over 2, 3 pi over 4, and pi. Alright, let's use this as our... Now we're going to create our 5x values. So from these values I just circled, I'm going to write in 0, pi over 4, pi over 2, 3 pi over 4, and pi. Class, which direction are we going to go? We're going to start over here on the right, and we're going left. Basically, this is a summary of how you would do PEMDAS as you evaluate those points. Okay? So we have x. I don't really need to multiply by 1. I just need to evaluate at what? Tangent. Okay? So let's go ahead and draw a quick unit circle. Class, they call it the unit circle because the radius is equal to 1. Anthony, tell me the order pair. No, it's not what you said. What is it? 0, 1. 1, 0. Partner B, tell partner A, what's tangent in terms of x, y, and r? This was on the last chapter test. Ouch. Yes, Juan. Is it the y? Thumbs up, thumbs down? Ricardo?
Thumbs up.
So tangent's not the y. Let's say it all together. Tangent is equal to? Y over x. Very good. Ouch. 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 This is back in January, probably the first week. Tangent is y over x. Why do I need that? Because now I'm basically going to evaluate tangent going around. Remember, this is an x. This is a y. So tangent, evaluate tangent. If I 0, tangent is y over x. So that's 0 over 1. Class, what's 0 divided by 1? 0. Okay. Throwing things at me? I can't see. In the box? You get it. I can't see it. Alright, pi over 4. With your partner in 20 seconds, I want an order pair at pi over 4. Feel free to use your trig paper plate if you haven't memorized it. Brian, order pair? What are you saying, Brian? Here's the clock. 2, 2, yes. Radical 2 over 2, radical 2 over 2. Okay, so what does that mean for us at tangent pi over 4? It's y over x, and I only need the numerator, so radical 2 divided by radical 2 classes, 1. Now we need to go to pi over 2. Y over x. 1 divided by 0 is? Undefined. 3 pi over 4. So this is 1 pi over 4. This is 3 pi over 4. It's the same order pair, but the x values will be negative. Class, what's radical 2 divided by negative radical 2? Negative 1. And at pi, tangent is? 0 divided by negative 1 is 0. So we have our x values. We're evaluating a tangent, and now we need to do what, class? Subtract 1 or multiply? It's the relationship between this 1 here and tangent is multiplying. -1 times tangent. So multiply by -1. Class, -1 times 0. -1 times 1. -1 times undefined. It's still undefined. -1 times -1. And -1 times 0. 0. Identify your letters, find the period, 5 x values. Now we're going to graph it. And today we haven't really done a good job of graphing more, but we'll eventually get there. Alright. Let's go ahead and graph this now. I need to arbitrarily put 1 on my graph.
The campus is now in a level 3 lockdown. Please proceed with the lockdown procedure until further notified. Attention. The campus is now in a level 3 lockdown. Please proceed with the lockdown procedure until further notified. Attention. The campus is now in a level 3 lockdown. Please proceed with the lockdown procedure until further notified. Attention. The campus is now in a level 3 lockdown.
Starting my video.
Please proceed with the lockdown procedure until further.
Alright, let's graph this. 0, 0.
Attention staff and students. At this time, we are in a current lockdown level 2. Once again, we are in a current lockdown level 2 at this time. This is not a drill. Once again, we are in a level 2 lockdown. Once again, this is not a drill.
Alright, pi over 4 is at -1. Okay, pi over 2 is undefined. Back in August, when we said something was undefined, what did it look like? Yeah, it was a vertical asymptote. So at pi over 2, it's actually a vertical asymptote. Three pi over 4 is 1. And at pi, it is 0. Alright, you're asking, how can I get a graph out of this? If you expand your points, let me see if I can do this in a different color. Get them in pink. You're basically, when you say more, you're basically repeating what you've done, and you just kind of do it again. What does that mean? How many points do we normally graph? On the x-axis, how many do we have? 5. 1, 2, 3, 4, 5. So if you repeat it, look. 1, 2, 3, 4, 5. Does that make sense? And I'm going to do the same thing the other way, and you have to, you count the asymptote. 1, 2, 3, 4, 5. And if you actually made the table, which is, you wouldn't really want to do that, but if you did, you basically would have, at every 5th point, you'll see that it's an asymptote. So what should you have on your graph so far? You'll have 3 asymptotes, because they're undefined at those locations. And in between them, you should have 3 points. And if you see what I'm doing here, if you watch my finger and the pencil, you have the asymptote. At this point, it's going to be 1, so I'm going to go ahead and put a point here. As you move over to the next one, it's 0, and the next point should be a -1, so go down here and have -1, and then the asymptote. Same, Same. Alright, let me draw the graph now. The next 2 days we're going to be graphing tangent and cotangent, and tangent looks like I call it a snake. Alright, some clues about tangent and cotangent. Everyone say linear. Those 3 points between the asymptotes will be linear. They'll be in a line. So because the a value flipped our points over the x-axis, it would normally have the 3 points here. It would actually be literally a straight line, those 3 points. And then it kind of curves. So it looks a little bit different than your sine and cosines. Definitely think back to your unit circle or how you would evaluate those points. But it's essentially the same thing, just looks a little bit different.